This is lesson 9 from Metal Technology over forging. If you're following along in your book, it's chapter 17, pages 261 to 274. Make sure that you're utilizing pause on this video whenever you need to, if you need to go back and draw an image, or if you need to finish your key term descriptors, because I will be moving through this relatively quickly. So again, please make sure that you're using pause. Here we go, Metal Technology lesson number 9. This first picture up here is of a guy that is doing a process called hand forging. So as he is forging, what he is doing is he is applying heat and pressure. So if you look here, this is a heated piece of metal. So this metal has been heated. He's holding it on something called an anvil, which is one of our next key terms, and he is applying pressure up here by swinging a hammer and hitting it onto the piece of metal. This is what a blacksmith does. So there's a lot of things that have been forged in this method. So swords, knives. You're going to forge your screwdriver blade using either this option or what we call a drop forge option. The anvil, the picture of the anvil down here, is broken down into different parts. So if you would look and notice down here, there's something called the throat, the bick, table, face, hardy hole, pritchett hole, and hanging end. We are primarily going to work on the face. So this gentleman up here, he is hammering on the face of the anvil. Now you also see that he's holding whatever his project is with a pair of tongs. So you always want to make sure that you use a pair of tongs, because the heat from this will transfer up, and even though you have gloves on, it's not going to be enough protection for that. So you definitely want to make sure that you are using tongs. This next key term is something called drawing out. In the picture up here, the arrow is supposed to be representing and showing the metal being elongated. We won't probably do this in class. We can demonstrate it if you would like to see, but what is happening here is this piece of metal is being elongated, and as it's being elongated, you can see that the diameter is decreasing. So if you could picture yourself grabbing like bubble gum in your mouth, and when you pull it out, it elongates, but it gets a lot thinner. So that's what drawing out does. There's something called upsetting. So if you look in this next picture down here on the bottom, this metal back here or down here is being heated. So it has been heated somewhere outside of what's going on here. Then the person that is forging, he's doing the upsetting. He has in his hands a pair of tongs holding the project, and then if you look real closely up here, you can see that he is applying pressure. So when he applies pressure, when he hits this down in this direction, what's going to happen is the bottom of this is going to bulge. So it thickens or bulges at the end of the piece of metal. That's what upsetting is. The last key term for this slide is drop forging. This is the type of forging that you are primarily going to be doing in Metal Tech class. For me, you will be making your screwdriver blade using the drop forge. What happens is the operator will have to stand here and grab this handle. So as you grab the handle, you're going to be pulling the handle up, and then once you get it to its height, you just quite simply, like the name states, you just drop. So when it drops down, the weight of it is going to hit this heated workpiece. This is really important. So down here, when you're looking, the workpiece here, notice how it's kind of represented with this orange color. Our project needs to be hot. So when our project goes into the forge, where we drop down, we're applying heat and pressure to reshape. Some technology that we actually do not have in this classroom, but you need to know about, is press forging. So when you have press forging, it's similar to drop forging. However, the difference is there's no impact. What happens is this hammer and the punch will start gradually working its way down, and when it comes in contact with your workpiece, it's going to squeeze it out. So kind of like a silly putty or something like that. Obviously it's going to be a lot more difficult than that, but as you apply the pressure, the machine's going to push down, and then it's going to cause this squeezing type of effect. So over here would be the end result after press forging. Next one is roll forging. Again, technology that we do not actually have in our room, but is widely available in industry. This is a roll forging machine. On roll forging, what happens is these rollers will spin. So as they're spinning this piece of metal that's right here, you look right in this area, this is a piece of metal. Look real closely here. That's being pulled in. It's being pulled into the center of the machine. The way it's being pulled in is it's grabbing in here and it's pulling it through. The next one is something called rotary forging. Rotary forging is made, you make round objects. So as the machine is pressing, it's kind of a combination of press forging and kind of similar to roll forging. So the machine will grab your project and it will turn it, and as it turns it, it's going to give you a round object. So the best thing that I could find, something that we could all see and relate to, is the wheels on a railroad car. So over here, these wheels have been made using rotary forging. Rotary forging uses round products, or excuse me, forms round products, uses a straight die, an angle die, and application of pressure from two sides. So again, application of heat and pressure is what forging is. This next slide is something, this next key term is cold forming. When you have cold forming, what we've got is a picture of a series of bolts. It's actually one bolt, and it shows you its progression of how it is made. So this bolt right here, where the pointer is, that's just a bar stock. It's a round piece of stock where the bolt is at the early stage of its life. Goes through a series of forming to where, as you can see here, this is the same thickness as here, but it was drawn out. So this would be a real example of something that was drawn out. So notice the difference in the length. Next step is where it actually is going to form the round part for the head. So this would be the upsetting portion. Same deal, it goes through another drawing out here, and then by the end we're going to have a bolt with a finished head and the screw threads. So that's cold forming. This next thing is something called intraform. Intraform is actually what we call a swagging process. So this swagging process, the main thing that you need to know with intraform is that it is chipless machining. So when you have chipless machining, you do not waste any material. So this object over here was made on something called an intraform machine. This view that I'm drawing here with my yellow arrow, this is a cutaway view of this object. So this object over here on the left has been cut in half to show you the inside grooves, and there's some different channels and things like that. So again, it's chipless machining. That's what intraform is. The essential questions: describe a product that's been forged, explain what the product does and what its characteristics are. So you can give me examples of anything from like a sword or a knife or a screwdriver blade, any of those sorts of things, a railroad car wheel that we learned about on rotary forging, anything like that. Pick something, list it, and explain. And then the next one, why do you think they choose to forge metal into shape instead of cutting it into shape? So what I want you to think about here, your little hint would maybe be, think about the amount of material wasted, and compare that to the amount of material that would be wasted when forging. That's going to do it for lesson 9. As always, make sure that you come see me if you have any questions. Thank you.